So I know that 12 and 13 are going to bug y'all for good reason. I mean, you're doing logarithms, you're doing a lot of upper level stuff, and these just work out weird. And something weird happens in them. So we had to change this one, but I'm using the summation formula for geometric sequences. The first term that I care about times 1 minus the ratio to the n over 1 minus the ratio. And the sum is negative 819. It would be equal to the first term, which is given as a 1, which is nice, over 1 minus, and if you don't wrap this in a negative, you're going to do something silly, like say that it becomes plus 4 to the n, the unknown, over 1 minus a negative 4. And we're going to do some cleanup stuff here. Negative 819 equals 1, which is understood, so I'm just going to drop it. 1 minus a negative 4 to the n over 5. I'm going to 5 both sides, and that's going to give me negative 4,095. So this is kind of when it starts getting a little weird, right? That equals 1 minus a negative 4 to the n. We're going to take away 1 from both sides. Negative 4,096 equals a negative 4 to the n. And if I divide out the negativity here, I don't get to enter the parentheses. But I end up with 4,096 equals negative 4 to the n. Now, you can divide out the negativity here, and you're still going to have a problem. I'm just going to leave it like this. It would not make much sense to say a log of base 4, of base negative 4, of 4,096 is n. Because the calculator can't do that. All right? So you have to make it positive. Now, the vast majority of you understand change of base. ln 4096 divided by ln 4 is my answer. N equals 6. Now, this does work. You know, go back to this idea. This guy you had right here, that guy right there. You take a negative 4 and you raise it to the 6th power, and you do it properly with parentheses. That's something some of y'all just don't want to get in your head because you like to do this. But my calculator told me it was negative. No. You take a negative 4. If you raise a negative to an even, it's always positive. That should have been drilled in your head. It works. So n is 6. There are limitations of what technology can and cannot do. For one, it can't think about why it might need to drop a negative sign like you can. Okay? Technology doesn't think, it just does. All right, 13 is another one of these summation problems. I don't remember if it comes up weird or not. I don't know, we'll see. Oh, let me undo that. I didn't mean to clear the entire page. All right, so aside from the few mouth breathers I have that haven't figured out that means sum of. All right, now also pay attention that this is in the correct form. It's in that form of a geometric sequence, and it also starts at 1. Something safe to do if you want the first term is to always plug in a 1. That's going to be 3 to the 0. 2 times 3 is 0 is 2 times 1, which is 2. But the first term is 2. So the sum of n things must be the first term times 1 minus r to the n over 1 minus r. And I know the sum is 19,682. And it must equal the first term of 2 times 1 minus. The ratio is always the guy inside, 3 to the n. I'm going to wrap it even though I don't have to. It's the negatives you have to worry about. And that's sitting over 1 minus 3. All right, let's see what happens. I know that 1 minus 3 is a 2, a negative 2. And I know that 2 over negative 2 is a negative 1. So I have a negative 1 minus 3 to the n. And it's still equal to 19,682. So I'm going to divide out that negative That's going to give me negative 19,682 equals negative 3 to the n. And I'm going to divide out this negative again. And this one works out okay because we end up with positive. All right. Oh, Milbrath messed up. Let me go back. I got in a hurry because if you can tell, it's already after hours here. I'm working overtime for y'all and I ain't getting paid for it. Okay, so I divided out a negative symbol and I forgot I had a 1 here. 1 minus 3 to the n, which I have to take away from both sides. So negative 1900, negative 19,683 is negative 3 to the n. And then I divide out that negativity. So positive 19,683 is equal to 3 to the n. And then I do log as base. A log whose base is 3, base exponent argument of 19,683 is equal to my exponent n. And again, if you hadn't figured out change of base, like I don't even know where you've been, Maine. We've been doing it now for 2 straight weeks, I think, on a regular basis. So ln 19,683 divided by the natural log of 3 is that nice whole number 9. And that's why the answer is 9. So there you go. I worked overtime for you. You're welcome. I'll see most of y'all Wednesday, I guess. Now, I'll see a lot of you Tuesday. Anyways, I'll see y'all later.